The transport of electricity from power and production plants to the final clients occurs along transmission and distribution lines through the relevant substations. In many of these steps, the energy is measured with a meter to quantify how much of it is transferred from one side and then absorbed by another. And in this way, the energy transaction can be matched to its corresponding economic value. The meter is a small, easily accessible device, and its verification and calibration do not involve any particular difficulties. To calculate the energy, the meter measures voltage and current over a certain period of time. Eventual measurement errors accumulate, and although they seem insignificant at the time, they can result in significant imbalances, which can favor one of the two parts over the other. The situation is different when the electricity is measured at a point on the medium or high voltage network. Under these conditions, other networks, points of production or loads, and more frequently, wind farms or photovoltaic systems can also be connected. As current and voltage are too high to be measured directly by the meter in these cases, instrument transformers, which adapt the voltage and the current to the meter, are attached and used. These devices too can be affected by errors, and their performance changes over time due to wear and aging. This bulky equipment is connected directly to the high voltage grid and is difficult to check except by disconnecting it from the network. This involves de-energization at the point of installation, an operation which increases operating costs and leads to a suspension, even if only temporary, of the energy supply. S.p.A has tried to solve these problems and has undertaken research to develop innovative equipment and thus make the calibrating and testing operations as non-intrusive as possible from a logistical point of view and with no impact on energy transit at the point in question. The new methodologies are based on the availability of reference measuring systems based on innovative technologies, the adoption of live line working methods, the design and implementation of new equipment. The measurements obtained by the voltage and current transformers are compared with those obtained from transportable reference measuring systems, the accuracy of which is kept constantly under control in S.p.A laboratories. The new equipment allows for the connection of the reference measuring systems to the high voltage network without the need to interfere with that already in place. The live line working methods allow authorized personnel to operate safely on live power lines. The current reference measuring system can be installed directly on the live line. To measure voltage, it is necessary to insert additional equipment. The voltage sensor is installed between a live line and ground, draining a non-negligible current and thus generating an electric arc, a phenomenon which, if not controlled, can be harmful to the equipment and people performing the measurements. It is therefore necessary to use a disconnector switch, a piece of equipment in common use, which, however, is normally resident in a network point and is not easily removable or transportable. To solve these problems, we started with an insulating rope, a special rope which is able to maintain the insulation between the live parts and those on the ground. If the current to be broken or made is minimal, the arc is barely noticeable and the operation can be performed by hand. In the case of higher currents, it is necessary to have equipment able to automate the process. To test the idea, a prototype was set up and laboratory tests were carried out which confirmed the feasibility of the device. This led to the creation of a structure designed to be transported, assembled and disassembled quickly and easily, without the need for special calibration procedures. The Simplified Transportable Disconnector, or STD. Equipment consists of 3 elements placed on trolleys, one of which deals with the commands for assembly and for operation. The 2 main carriages are aligned, the third is positioned at a distance. The lighter accessories are mounted by hand on the ground, the fixed contact, the wire that creates the link with its collecting reel. During assembly and installation, you must be very careful not to lose the insulating properties of the rope. The most complex phase of the installation would be lifting the insulators which support the terminals of the switch to bring them to a height of several meters from the ground and isolate them. However, with the STD, this operation does not require external lifting equipment or working at height. It is automated and can be comfortably managed from the control panel by staff. The distance between the carriages is fixed, taking into account the network voltage, establishing the contact start and end positions accordingly. Now everything is ready to start the measurement. What appears as a single discharge is actually a succession of arcs which takes place over a very short period of time. The voltage is AC. Once a suitable distance between the contacts is reached, the probability of discharge is 0. The sensor is connected and the control measures are carried out. We are in Rondissone, in the main station of the Italian transmission grid. Terna is the company owner of the network, responsible for the transmission and dispatch across the whole of Italy. Terna has an internal structure which is envied all over the world, specializing in live line working. The leaders of this team have followed all the activities relevant to the development of the equipment, facilitating the testing phase with their precious collaboration. Once the tests of the voltage reference measuring system are complete, the current one is verified with satisfying results. The on-site test was a success. The prototype has passed the test in the field and the equipment has been tested. These reference systems and devices are available for a large-scale implementation and are useful for all those connected to the high-voltage electricity network who will be interested in checking their own measurement systems. The synergy between RSE and other Italian companies such as Terna and Remazel, which has created the simplified transportable disconnector, has made it possible to find a solution to a problem that has been encountered worldwide for many decades.